Okay, if I understand your question correctly, what you want to do is take a cylinder and taper it, that is, scale this top circular face. And in Tinkercad, you can't do that. However, since basically what you're asking for is a truncated cone, the top, right now you'll see over here in your sliders, is set to 0. But if you scale that out, you can specify the radius of the top. I'm going to go ahead and smooth out the sides, maybe take the base radius and crank that up a little bit, change the color here so it's a little bit easier to see the edges, and Tinkercad does a great job with that, and that would work for you every time. If you want to use SketchUp, you can. It's a little more intuitive and probably would solve what you're asking to do here. So I'll just type in C for circle. I'll click here, pull out along the red axis, give it a radius of 20, then use the push-pull tool, pull it up 20, and then I can take and select this top face, type in S for scale, and then hold down my Option or Alt key and scale it like so. So that's pretty easy to do. Now if you want to scale it to a specific size on the top, say give it a radius of 5, then you can just take and draw a line here. So we have to mouse down here along an edge to get the center snap to show up. I'll click on the center and I'll go out along the red axis or the green axis, 5. And now when with this face selected again, now when I type in S to scale, I can go ahead and pull that down to 5, and then repeat the same thing here. Pull this out, go 5, and then grab that face, S for scaling, and then hold down my Option key and pull it in like so. And then you can just take and erase these extra edges here so that they don't goof up your Tinkercad model. Apologize for my voice, I'm getting a cold or something here, but in any event, we're just going to go ahead and take and export this as an STL file. I'll call it Untitled 5. Then we'll jump back into Tinkercad here, import, choose file. There's our STL file. It's going to fit on the build plate just fine. Come in true shape and true size, and there it is. Now, what if you want to do something just a little more complicated? Say instead of you want this to be lofted with this circular base, but you want the top to be a squarish type shape. Say it's a piece of ductwork that's going to go from round tubing to square tubing or whatever. Well, we'll just jump back into SketchUp, because to do that in Tinkercad would take an awful lot of work. So I'm just going to go ahead and undo this. Just back to my regular cylinder here, and I'll get rid of that little line. So with this in place now, I'm just going to go ahead and type R for rectangle, and let's see, I'll tip this over just a little bit like that. There we go. See, a little bit easier here. And I'm just going to go ahead and pick an endpoint there and come down. I want to make sure that all 4 vertices of the rectangle or the square. If I want a square, I just need to start up a little bit higher, like so. It's not a perfect square, but lots of ways that you could do this. But for this example, this can work just fine. So I'm going to go ahead and select that right there, and then that breaks that into 4 individual arcs. And if it only breaks into 3 because one of these vertices doesn't split the circle or the arc, you need to redraw it. But we know that this is good, so now I'll just type in M for move, and when I mouse along this arc, right there. You can see we're pretty much perpendicular, so I'll just go ahead and click on that. Oops, I had the top arc selected. Let's click outside to deselect everything. And for move, just pull it in like that. And then come over here. Try to grab the center of the arc. Notice I'm pulling it in along the red axis. That's super important. And over here, I'm moving it in along the green axis. So there's our shape. Different edges show up at different times just because there's a lot of edges moving in this. But let's just go ahead and take now and export that as an STL file. Untitled 6. Jump into Tinkercad, import. It fits the build plate. And there it is. So let's see, let's go ahead and lighten that up so it's a little bit easier to see the edges here. And so we'll just kind of take a look at that. And it's looking pretty good. So you could go ahead and continue to build on top of this top surface or extend the bottom surface. But we've got our lofted transition now from a circle to a rectangular shape across the top. But I'm not going to be completely convinced that, because I brought it as an STL file, that I don't have holes or errors in it unless I check it in my slicing software. So it's just this selected. I'll export it as STL file. And then I'll jump into my slicing software here, import it. And there it is. Looks okay. But let's go ahead and slice it. So we'll do that. So there's our sliced model. Didn't get any errors. Let's go ahead and just examine it quickly by layers here. See if we have any holes. And it doesn't look like we do. So I'm going to call that good. Probably more than you want to know, but I just saw an opportunity here for a teachable moment. So there you have it.